Hey, hello everybody. Let's go ahead and take a look at section 2E.4, which is called Infinite Geometric Series. Now, before I go ahead and talk about the infinite geometric series, let's just get an idea of what we're actually referring to when we talk about an infinite series. If we go ahead and take a look at this notation here, this would actually represent what is called an infinite series. And the reason why is because we're actually adding up an infinite amount of terms of a particular sequence. So we're taking a look at the sum of the first infinite terms, which is the exact same thing as the summation of u sub I from I is equal to 1 to infinity. Now the question is what is this equal to? You're adding up an infinite amount of terms. I think it's pretty intuitive, rather intuitive, to be able to say that if we're going to add up an infinite amount of terms, well, shouldn't that actually be equal to infinity itself? And it can be. And for these types of situations, what we're going to say is that the series is divergent, or you can say that the sum diverges to infinity. And those are two ways which you can talk about any particular infinite series where the sum is equal to infinity. Now, this may be less intuitive, but it is also just as valid. Is that if I take the infinite series from I is equal to 1 to infinity of u sub I, this actually equals to some number. It becomes a constant, where this constant, of course, is not equal to infinity. If we actually come across this situation, what we say is that the series is convergent. Or in other words, when you add up all the terms, the infinite amount of terms, you actually come out with the series actually converges onto a particular value, in this case, C. Okay, so let's take a look at what needs to happen then. And we're going to focus, first of all, on geometric series, and we're only going to look at geometric series. Now, if the absolute value of R, because again we're talking about a geometric series, is greater than 1, okay, then the infinite series is divergent. Okay? So it approaches infinity. On the other hand, if the absolute value of R is less than 1, then the infinite series will converge to a particular value called C. Okay. Now, if this is the case, how do we actually go ahead and evaluate what that value is? Now, in order to evaluate the infinite series, the infinite geometric series, all we need to do is take the first term and divide it by 1 minus R. Okay? So let's go ahead and take a look at an example then and determine whether or not a particular infinite geometric series is actually going to diverge or converge. And if it converges, what does it converge to? So here we go. Here's our example. We have 0.8 with the bar above the 8, which means, of course, 0.88888, and all of those 8s will continue to infinity. Now, if we really wanted to go ahead and write this in terms of a series, notice that there's no plus signs here. We need to go ahead and include plus signs as well as listing all of the terms of the sequence that would generate all of these 8s. And this is what that series representation would look like. It would be 8 divided by 10, plus 8 divided by 100, plus 8 divided by 1000, and I would just continue on. So hopefully it is very apparent that this right here, which is the geometric series representation of this. Now, if we go ahead and take a look at what u sub 1 is, u sub 1, of course, which is the first term of the infinite geometric series, is going to be 8 over 10. And we can very easily show that the ratio is going to be 1 over 10. If we know that if we have these two pieces of information, I can then go ahead and actually evaluate the infinite geometric series because of the fact that the absolute value of r, which in this case is 1 over 10, is less than 1. Since this is true, I can now go ahead and use this formula here to actually come up or determine what this infinite series is equal to. So let's do that. Here's s of infinity. I'm sorry, we're going to write that a little bit better. Here's the infinite geometric series. This is actually going to be equal to 8 over 10 divided by 1 minus 1 over 10. So what this becomes then, this becomes 8 over 10 divided by, that's going to be 10 over 10 minus 1 over 10, which is 9 over 10. So this is actually going to be equal to 8 over 9. So this representation here, which is 0.8 with the bar over it, which can also be represented as an infinite geometric series, actually is equal to 8 nines. Now, if you go ahead and put that into your calculator, sure enough, you're going to come up with this representation, which of course can then be represented by the 0.8 with the bar over it. So, to wrap things up, remember that we have what is called an infinite series. If we know that an infinite series is equal to infinity, we said that the series is divergent. If it is equal to a number that is not infinity, we say it is convergent. And then we take a look at the geometric series. For infinite geometric series, if the absolute value of your r is greater than 1, we say that the infinite geometric series diverges to infinity. If the absolute value of r is less than 1, then we say that the infinite series will converge to a value of c, which can be calculated by taking the first term of your geometric series and dividing it by 1 minus r. Okay? Good luck.